We're going to spend some time in this lecture talking about pseudoscience. And you might be thinking, well, I thought we were going to learn about science, but I think it's really important to learn about pseudoscience and sort of how to protect yourself against thinking that pseudoscience is real or particularly useful. So pseudoscience, this is a picture of phrenology. This is kind of old school pseudoscience, and it thought that there was like different regions in your brain, and you could like study the shape of your skull to figure things out about people. And yeah, total total nonsense, total pseudoscience. But let's get into the criteria for pseudoscience. There's certain criteria for pseudoscience that you can look out for. Pseudoscience will often use science-ish sounding terms. This is a picture of a flux capacitor from the movie Back to the Future. Flux capacitor sounds really cool, sounds really interesting, nothing to do with science. A sort of more real world example of this is energy therapies. People purport to use these in order to cure their cancer, and energy therapies consist of interventions that are designed to interact with the biofield of a person. Key energy, or the biofield, is described as invisible psychophysical energy and energy, force, vitality, and strength. And I've been in biology for a long time. Um, the biofield, whatever that means, might actually exist, but I have never seen it. I have never read or heard about any evidence for it. And so even though you can talk about energy therapies in the biofield or whatever, they're just science-ish sounding terms. It's not a real actual phenomena that takes place. So first thing to look out for is, hey, if I start Googling terms based on articles that I'm reading, are they actual real terms, or are they just kind of weird stuff that is pretty made up? The other thing is anecdotal evidence, sort of the second thing to look out for when you're searching through articles and trying to figure out if you're reading something real or something pseudoscience. So like my batting average is perfect while wearing this necklace. I don't know if anyone out there is a baseball fan or not, but these necklaces today and more so a few years ago were like huge in baseball. It's like, oh, if I wear this, I'm gonna be great. But like, so what? It has nothing to do with the necklace itself, and your numbers. Just because you as an individual hit really well while wearing the necklace doesn't mean that it actually did anything, right? It just because one person claims something, that doesn't mean that it's actually real. It doesn't mean it actually had an impact. And this happens all the time, and I'm certainly susceptible to it. But somebody will come to me and say, "Hey, this intervention worked for me personally. Maybe you should give it a try." And sometimes it does work, but you cannot use anecdotal evidence to make scientific claims. You need large numbers. You need to look at a lot of different things. You can't just say, "Oh, my friend Timmy says that the necklace makes him a better baseball player." If they took half the league, or let's say they took the National League and they made them all wear necklaces, and they took the American League and said you guys can't wear necklaces, and the National League hit better, then you would be able to say, "Oh, okay, those necklaces do work." But one guy saying it, not science, pretty pseudoscience. Um, Extraordinary claims without extraordinary evidence. So if you're going to make a fairly radical claim, you need to have a huge amount of evidence for it. This is sometimes called the Sagan standard. Um, but if I were to say something like, "Hey, I saw a unicorn today," you would probably say, "Well, prove it." If you're going to claim something like, "I saw a dinosaur," or "I saw a unicorn," you need to have evidence for it. And you have pretty good evidence for it too. You need to maybe bring it in so other people can see it, or take a DNA sample, or at least get a picture at a minimum. And so oftentimes people will make very, very radical claims without having very, very radical evidence. So if you see something that makes a ton of massive claims and sort of pins it all on the one individual that they studied, it's probably pseudoscience. You see this all the time with evolution. People say, oh, my experiment showed that these bacteria aren't progressing through generations. They're not able to add any new information. And so my one study is going to disprove all of this evidence that there is for evolution and all of these um, studies and evidence and research that exists. They're going to use one piece of evidence to disprove all of that. So evolution is another spot where people have not great evidence, but they're making a huge claim. So pseudoscience will often make extraordinary claims without extraordinary evidence. So this next one is making claims that are unfalsifiable, which, the last example kind of was if I say I saw a unicorn, you can't, there's not a ton that you can say. Well, actually, that would be falsifiable because you can just say, well, prove that. But if I say something like the reason that it's cold inside my house is because there's a ghost and only I can see the ghost, that you can't say anything otherwise. You cannot prove or disprove that I have a ghost in my house, and that's the reason that I feel cold. Okay, so making statements that are what is referred to as unfalsifiable is pseudoscience. The ghost is giving me arthritis. The spirit of my grandmother is the reason that I'm able to, turn on the light. You know, you can't if you can't directly say no. Well, it's not. Here's a test we can do for it. It's probably a pseudoscientific claim. So we did everything inside a bubble. By this one, I meant that the study or the research has no connection to previous research. They're just sort of staking out on their own, and they're starting things, and they're making claims about things without pinning it back to research that has been done. Science is this iterative process, and it all builds on previous research. And so if you're just starting from scratch, if you're not having everything underpinned to prior research, probably pseudoscience. The next thing to look for in pseudoscience is that pseudoscience is very often not peer reviewed. And so I talked about peer review in another lecture, but peer review is the process of handing your research over to other scientists and letting them look at it and letting them check your logic, check your work, maybe replicate your research, maybe use their knowledge of what you're talking about to say, hey, this is good, or to say, hey, you need to do this experiment again, you need to check this. And so this is sort of the way in which scientists are able to check each other's work is through peer review. And so if it's not peer reviewed, it isn't necessarily pseudoscience, but it's probably pseudoscience. It's starting to get into the realm of pseudoscience. The other thing is, if they don't check their work either, if they're never issuing corrections on anything that they're doing, despite people claiming, hey, there's problems with it, that's also pseudoscientific. So you have to have people, you have to correct your work as well as have others. So let's review some of the things that you see in pseudoscience. Science-ish sounding terms, things that sound like they might be science but aren't actually really science. People using anecdotal evidence. Oh, hey, this thing worked for me. This necklace made me a better hitter. Extraordinary claims without extraordinary evidence. So the one you see here all the time, I talked about unicorns, but the one you see here all the time is people will claim to have disproved evolution using like one study, whereas the reality is evolution has been proven time and time and time again to be true. And so, just one experiment's probably not going to disprove 150 years of evolutionary thinking. Claims that are unfalsifiable. The ghost makes my tea every morning. Things you cannot definitively disprove or prove. People working in a bubble or not basing their research on previous research. People eschewing or people avoiding the process of peer review. So not submitting your work to publication so that other people can look at. And not issuing self-corrections also is something that is pretty pseudoscientific. So this is going to be connected to a discussion assignment that you guys are going to have in the first couple of weeks. So yeah, make sure to check that out.